All right, this is our last exponent rule that we're going to learn about. There will be another video where we put all these rules together, but this is the last rule. It's called the power rule, and it is used for raising monomials to a power. And you can see here that we have x to the third power, and then all of that is raised to the fifth power. So we're taking something that already has an exponent and taking it up a notch, so to speak. So think about what x to the third means. X to the third means x times x times x. And so what we have is x times x times x 5 times. So I'm going to write all that out, and we'll see what that equals. So you can see we have 5 sets of x. So, or of x to the third. So we have 3 x's 5 times. So if you count all those, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have x to the 15th power. So, as always, there's a shortcut. You could have done x to the 3 times 5 power and gotten 15. So the rule for the power rule is if you have a base with a power to a power, then you take the powers and multiply them together. So it will be a times b. Now, that seems really simple, but it can get complicated, especially when we throw in coefficients. So make sure you're paying attention. These first few, super easy. You've got x to the 8th power to the 3rd power. You just do 8 times 3 and get 24. Next one, if you have s to the 2nd power to the 5th power, you end up with s to the 10th power, because 2 times 5 is 10. And then you've got 6 times 4. I'll let you guys do that one. If one of the exponents or both of the exponents are negative, you do the same process. Just remember, you can't have a negative exponent in your answer. So for number 4, 2 times negative 4 would be negative 8. So we would have to change that to 1 over y to the 8th power. Or number 5, if we have b to the negative 3rd to the 2nd power, then that would be negative 3 times 2, which would be b to the negative 6th power, which would then be 1 over b to the 6th power. Or if we had one like 6, where we've got negative times negative, we would end up with positive 20, and that one's done because the 20 is positive. You don't have to rewrite it or change it to a fraction. And just like before, the same rule applies if you have multiple variables. So for this first one, you're going to do x to the 4th to the 2nd power and y to the 6th to the 2nd power. So you're going to have x to the 8th and y to the 12th. Think about it as distributing the exponent to the other exponents because that's basically what you're doing. You're multiplying it by the 4 and then you're multiplying it by the 6. So if you had one like 8, you would have a to the 15th power and then b to the negative 10 power. And then you would say, oh, I can't have a negative. So I would have a to the 15th over b to the 10th, like so. Number 9 is basically just like that, so I'm not going to do that one. Let's talk about number 10, though. Number 10 is one that gets people. They do this, and that's not right, because they're forgetting that a has an exponent of 1. So it's really 1 times negative 5, which means it's a to the negative 5th, b to the negative 15th. And when that happens, that means both of those are negative, so they both have to go to the denominator. If everything moves to the denominator, you got to put a 1 in the numerator. It's like a placeholder. It's telling you, hey, this is a fraction. You got a 1 on top. Okay? So then 11 is a lot like 10. Let's do 12. So 12 just has x to the fifth, y to the negative 2, z to the third, all squared. So that means every one of these exponents is going to get multiplied by 2. And then you have to look at it and say, do I need to move someone? Yes, you do. You need to move y to the negative fourth because you don't want that negative. So you're going to have x to the 10th over z to the 6th all over y to the 4th. So that is the final answer for that one. Okay, so use what we've talked about here to do these that I skipped. On the next page, we of course have power rule with coefficients. When you have power rule with coefficients, what you have to remember is the coefficient has an exponent of 1. So that means that you have 1 times 3, which is 2 to the third power, and 5 times 3, which is x to the 15th power. But then, because you can actually do 2 to the third power, you're going to do that in your calculator. So just use the exponent button, put in the 3, and so you're going to get 8 x to the 15th power. So when you're raising a monomial to a power, you're going to actually raise the coefficient to that power, and you're going to multiply the variable exponents with the that already have the variable there. All right, and then just like before, if you have a negative exponent, you got to move it to make it positive. Now, if you end up with a negative coefficient, that's okay. It doesn't have to move. It's just just the exponents that have to move. So this first one is very similar to the one we just did. So you're going to have 4 to the third power and r to the 6th power, and then go do 4 to the third power in your calculator. So you get 64 r to the 6th power. Now, if you have a negative number, it is super important that you put that in parentheses when you put it in your calculator. If you have an odd number, it's not going to matter. So if your exponent is odd, whether you have parentheses or not, it's not going to matter because it's an odd number. But what if that would have been a 4? Oh, it does matter. That's because when you're multiplying something by itself, the negative switches every time. So think about, you've got negative 2 times negative 2. That would be negative 2 squared. That would be 4, not negative 4. Then if you had negative 2 times negative 2 times negative 2, that would be negative 8. Because negative 2 times negative 2 was positive 4. Positive 4 times negative 2 is negative 8. Then, if you go to the next step, which we did in our calculator, negative 2 times negative 2 times negative 2 times negative 2, you get positive 16. Because you had negative times negative is a positive, times negative is a negative, times negative is a positive. And then when we got to the fifth, which was the original problem, you switch it back to negative 32. Now I'm going to erase all that, but that is really important. And it's why you will always see me put negatives in parentheses when I put them in my calculator. So negative 2 to the 5th power and x to the 5th power are what we're talking about. And negative 2 to the 5th power is negative 32. X to the 5th power is just x to the 5th power. No negative exponent, nothing needs to move. All right, what about number 3? Number 3 is actually negative 1y to the negative 3rd power, all raised to the negative 2 power. So what you really have is negative 1 to the negative 2 power. Remember, you need it like this. And y to the 6th power. because negative 3 times negative 2 is positive 6. So if I do negative 1 to the negative 2 power, I'm going to get 1. Let's just see what would happen if I left off my parentheses. I would have gotten negative 1. That's not right. It is 1. Negative 1 times negative 1 is positive 1. Now I know this has a negative 2, so what you're talking about is 1 over 1 squared. Well, it's still negative 1 times negative 1, which would be 1 over 1, which would still be 1, not negative 1. So make sure that you use your parentheses when you're dealing with negatives. You can use them with positives too, but you have to use them with negatives. So back to here, negative 1 to the negative 2 power is 1. So I have 1 y to the 6th. Well, 1 times y to the 6th is just y to the 6th. So I actually don't even need the 1. It's just y to the 6th. Okay? Oh my gosh, what if you get a fraction? Well, if you get a fraction, you're just going to do the fraction to that power like you would if it were any other number. So make sure you come out of the fraction, then push the exponent button so that it will raise it to the right power. So we know because of this 1/8 that we're going to have a fraction answer like this. What we have to figure out is, where does the s go? Well, we've got negative 5 times 3. So that's s to the negative 15. Well, s to the negative 15 needs to go to the denominator, so it can be s to the positive 15. So that's our answer on that one. So what if our exponent is negative? So we would have 4 to our negative 4 power, and then p to the negative 8 power, because 2 times negative 4 is negative 8. This has to go in your calculator. This is going to go in a denominator, but we got to find out what this is first. So we're going to do 4 to the negative 4 power. That's 1 over 256. So that means I'm going to have 1 over 256 p to the 8th, because I already knew this negative meant that that was going to have to go in the denominator anyway. So I encourage you guys to work these out in sections and then put your answer together at the end. I'm not going to do number 6. Number 6 is kind of like number 1 and number 4 put together. Let's look at number 7. So I've got that 1/3 that has to be raised to the negative 4th power, like that. That's going to give me the whole number 81. Now, hopefully this makes sense to you, because if a negative exponent makes a whole number, like look at these two right here beside of each other, or on top of each other. This negative exponent made this whole number a fraction. So a fraction with a negative exponent has to become a whole number. So hopefully that is like, oh yeah, that makes sense. So we've got 81, and then we've got r to the 12th power, because negative 3 times negative 4 is positive 12, and then s to the negative 16th power, because negative times positive is negative. So that means this guy has a negative exponent, and it has to move to the denominator. Now it's the only thing that has to go, because everything else has a positive exponent. 81 has a positive exponent, or it wouldn't be a whole number like that. So it got to go. It went from the denominator up to the numerator because of this negative, because technically it already was negative to be a fraction to start with. No, your mind is blue. All right, let's see. Number 8 is pretty straightforward. I'm going to let you guys finish those. So you've got 6, 8, and 9 there to do, and we'll check on those in class. All right, that's that for that video. The last one I will do separately. It's about putting all of these rules together.